Hello, in this video we are going to be looking at the key characteristics of a quadratic function. A quadratic function, as we can see here, when we graph it, creates a U shape, otherwise known as a parabola. We know that we have a quadratic function because of the degree of the polynomial, so we see an x squared here as our highest exponent, which is telling us that this is a quadratic equation. Okay, so the vertex. Looking at this graph, we can see the vertex, a lot of these will be similar to what we saw with absolute value functions. The vertex is either the highest or the lowest point on the parabola. It's where the parabola also changes from decreasing to increasing or increasing to decreasing. So this vertex is at the ordered pair 2, 4. The axis of symmetry is the equation of the line that passes directly through the vertex, and you would be able to fold the parabola in half on this line. It would meet up perfectly on both sides. So the axis of symmetry is always x equals the x value of the vertex. I like to say I can see it in the word axis, x is. In math, if you say x is in math means equals. So x equals, that might help remind you that it has to be x equals and you want the x value of the vertex. Opens up or down, I like to say up like a cup or down like a frown. This one would be up like a cup, so we're opening up. Because we're opening up, we can see that this vertex is the lowest point on the graph. When it is the lowest point, it is a minimum. In other words, if the parabola is opening up, it has a minimum. If it is opening down, it has a maximum. Roots are zeros. This is where we want the graph to cross the x-axis. Another word for a root or a zero would be an x-intercept. You can see that this parabola does not touch the x-axis at all. Here's my x-axis down at the bottom. Therefore, we would say there are none or no roots. Y-intercept is where the graph crosses the y-axis. So when we look at our y-axis, which is this axis here, our parabola is crossing the x-axis at 0, 8. Domain. Our domain, remember, x's go from negative infinity in this direction and positive infinity in this direction. Because we have arrows on the end of our graph, it's telling us that the parabola is extending on both sides all the way to infinity and negative infinity. Another way of saying this is all real numbers. Okay, so either of those would be acceptable. The domain is all real numbers, or in the notation we're using in class, negative infinity to positive infinity. The range. So remember, domain, you want to think left to right. Range, you want to think the lowest y value to the highest y value. So our lowest y value here happens to be the y value of the vertex. So the vertex is at a y value of 4, and then the arrows go up forever to infinity. The average rate of change, or the slope. I realize that a curve does not have a linear slope, so we're still going to find it. We're looking from x equals 3 to x equals 4. So I realize although this isn't a line, we can still find the average rate of change by counting rise over run. So we want to look at rise over run, or our change in y over our change in x. Our change in y is up 3, and our change in x is to the right 1. So our average rate of change is 3. Intervals of increase and decrease. This is similar to how it was in absolute value. You want to keep in mind that the graph is being cut in half here by the axis of symmetry. So when we're talking increasing and decreasing, the vertex is where the graph is changing from increasing to decreasing, or vice versa. So I'm going to mark the x value here. You really have two options as far as intervals go. On the left side of this graph, we go from negative infinity until 2, And on the right side of the graph, we go from 2 until infinity. It's up to us to decide which side of the graph is increasing and which side is decreasing. When we look at a graph, we read it from left to right. So looking at this side of the graph, as we go from left to right, this graph is decreasing on the left and increasing on the right. So if we're decreasing on the left, the decreasing interval starts at negative infinity and stops at 2. On the right, if we're increasing, the interval starts at 2 and stops at infinity. Okay, I'm going to go through one more example a little bit quicker than I did here. So this example, we can see the parabola is opening down, which is putting our vertex here at the top, and that vertex has the ordered pair 1, 4. The axis of symmetry has to be x equals the x value of the vertex, which is 1. Because the parabola opens down, it has a maximum. Its roots or zeros, remember this is where we want to look for the graph to cross the x-axis, which we can see it does nicely at -1 and 3. So I'm going to write those as ordered pairs, -1, 0 and 3, 0. This parabola has 2 roots or 2 zeros. The y-intercept is where the graph crosses the y-axis. That's at 0, 3. The domain, think left to right. So to the left, we're going all the way to negative infinity, and to the right, we're going to positive infinity. When we do range, we think low to high. Because this parabola has arrows that are going down to negative infinity, our lowest point on the graph is negative infinity. The highest point is the y value at the vertex, which is a 4. Be sure to include your range. Your y value of your vertex should have a bracket on it. Average rate of change, we're looking from x equals 1 until x equals 2. So again, I'm going to do rise over run or change in y over change in x. The y values are going down. Careful, this is 1. We go from 4 to 3, so that's down 1. And then from 1 to 2 is to the right 1. So -1 over 1, which is just -1. When we do interval of increase and decrease, I really like to tell my students to write negative infinity on the left, 1 in the middle, and infinity on the right. So whatever the x value of the vertex is here. You have 2 options for intervals. This side of the graph is -1 infinity until 1, and this one is 1 to infinity. So you just have to decide which one goes with increasing and which one goes with decreasing. If we look at the graph from the left to the right, this side is going up, increasing. This side is going down, decreasing. So our interval of increase would be negative infinity to 1, and decrease would be 1 to infinity.